Yeah, so the bulb lights up if you have voltage being produced. And in this case, what will happen is that you have uh, copper sulfate as the solution that will conduct electricity, but copper and copper will not produce any voltage. To make a cell, you need to have different reactivities of the two rods. So for example, zinc and silver, they have different reactivities. Is it work? So this is right to have silver, this is right to have zinc, but this is not electrolyte. It will not conduct electricity. Similarly over here, this will not conduct electricity, and this will conduct electricity, and these two are different. So yeah, D is your answer. All right. If anybody got a different result, or if anybody doesn't understand, so let me know. All right. So next question. In the circuit below, the bulb lights up. Okay, so it is definitely, electricity is definitely flowing, but this is not electrolysis. This is electrolysis, not cell, because you have a battery. Okay, so what happens? A solution of ethanol in water. That could be it, because you have ethanol in water, but then again, why would water ionize in presence of ethanol? It does to a very small extent. So this might not be a good answer. Primarily because they're saying it's one substance X. Okay. A solution of sodium chloride in water. Does this have ions? Of course it has ions. So will it conduct because of that? Of course it will conduct. So this is the one that provides us with the most ions. And based on that, I can say that this is going to be my answer. Let's still consider the other two. Liquid ethanol will not conduct because liquid ethanol will not have any ions. And then you have the next one is solid sodium chloride. Again, it will not conduct because it does not have any free ions. All right. Magnesium can be produced by electrolysis of molten magnesium chloride. Again, let's go over the process. You have molten magnesium chloride. Let's identify the ions. Magnesium positive 2, chloride negative 1. Magnesium is molten. There's no water. This will take electrons, make magnesium. The purpose of electrolysis is to make ions convert to atoms. And then chloride changes to chlorine with 2 electrons lost. And there you go. My option is going to be D. No, wait a minute. It's not D, it's C. There's a mistake in D because it's saying it's going to form 2 magnesium atoms. That's not the case because you're not going to get 2 magnesium atoms. Every 1 magnesium ion is going to get 1 magnesium, 2 electrons. What are the products formed at the electrodes during the electrolysis of molten magnesium chloride between carbon electrodes? Again, you have molten magnesium chloride. So you have magnesium ion, again, identify the ions, and chloride. This will go and make chlorine. This will go and make magnesium. So there you go, magnesium and chlorine. That is C. Right? So that's my answer, C. Okay. The diagram shows the electrolytic production of aluminum. What's happening? You have aluminum oxide. Remember, we get aluminum oxide, and that gives us aluminum ion, oxide ion. On one side, you're going to get aluminum because this ionizes. On the other side, you're going to get oxygen. We are not using water because if water was present, this will create hydrogen gas instead of aluminum metal. So I'm going to get aluminum. Now, because aluminum oxide is high in temperature, you need high temperature to melt it. Liquid aluminum is also going to be produced. It's not going to be solid aluminum because you have high temperature. Okay, so that's why you're going to get liquid aluminum and oxygen gas. Concentrated aqueous sodium chloride is electrolyzed. Okay, you have concentrated aqueous sodium chloride. You have NaCl making Na plus, Cl minus, H plus, OH minus. And they've told you that you're getting chlorine gas. Okay, what could be the pH of the result? Now you're getting chlorine on this side, but you're also getting hydrogen on the other side. So what is the pH? You have a lot of OH minus left. Remember that OH minus is something that is present in alkalis. So there you go. This is going to be the pH. pH that is greater than 7, and there is only one option, 11. Clear? If you have any questions, feel free to interject and ask. When dilute sulfuric acid is electrolyzed between platinum electrodes, which statements are correct? All right, so we have dilute sulfuric acid, platinum electrode. Platinum and graphite roughly work in the same manner because they're both unreactive or inert. And what happens? You have sulfuric acid, H positive from there, sulfate from there, and water, obviously, H positive and OH negative. I've told you in dilute solution, it's usually water that does the electrolysis. So hydrogen goes away, hydroxide goes away to make oxygen, this goes away to make hydrogen. Now you don't have much water. In fact, water has been broken now, and you're left with half the water. H2SO4 is still there, but water is less. So do we get oxygen at the anode? Yes. Do we get hydrogen at the cathode? Yes. And what about the rest? Sulfur is released. No, we are not getting sulfur. This is sulfate, does not discharge. The acid becomes more dilute. That is not the case because water is breaking down. You're getting less water. When you have less water, the acid becomes more concentrated, okay? Not more dilute. So that word is wrong here. So my option is 1 and 2, which is A. All right, moving on. The diagram shows the apparatus used to electrolyze lead-2 bromide. So I have lead-2 bromide. I'm going to get lead-2 ion and bromide ion. This is going to give me bromine. This is going to give me lead because I don't have water. So the moment I see this, I always try to write down my products or my ions. This makes it much easier for me to check the options. And I would suggest you do the same. Bromine atoms in the lead are converted to ions. Wait a minute. I don't have any bromine atoms in lead-2 bromide. I have bromide ions. It's not bromine atoms. Electrons flow through the lead-2 bromide when it is melted. Actually, electrons do not flow in the solution. Electrons flow in the wires. So that is the flow of charge. Sorry, it's the other way around. And the flow of electron is opposite to that. The ions in lead-2 bromide are free to move only when the solid is melted. That is true, because they wouldn't be able to move or do electrolysis if I don't melt it. There are no ions. This is my answer, but there are no ions in solid lead. There are no free ions. That would be correct. Saying that there are no ions is wrong. All right. Aqueous copper 2 sulfate is electrolyzed using inert electrodes as shown. Okay. Which ionic equation shows the reaction at the electrodes? So I need to know the ionic equation for the reaction at the electrodes. Again, I'll do the same thing. I write the ions, copper ions, sulfate ions, H positive, OH negative. Now least reactive ion discharges. So what is least reactive? I have copper as least reactive here and hydroxide as least reactive here. So this gives me oxygen gas and this gives me copper. And because I have carbon electrodes, they don't take part. So there you go. My copper ions are going to make copper. My hydroxide ions are going to make water. And yeah, the remaining part is H2SO4 being made. So the solution observations are solution will go from blue. This is the blue thing. And it will go colorless because I'm getting less and less of copper ions. Also, copper, the pH will increase because I'm getting more H positive and less OH negative. They're used up. It will become acidic. And this is a pink solid. So I will see a pink solid formed. Yeah, so my options are pretty straightforward. It is B. Okay, moving on. Now, just by looking at this diagram, I can see that the ratio in which gases are being made is 1:2 or 2:1 if you look from the left side. And where does that happen? That is H2O breaking down. So I know right away that I have a dilute solution in which water is breaking down. Okay, so what could be an answer? Copper 2 sulfate. Actually, when you have copper ions, they're less reactive than hydrogen, so they don't let hydrogen go. Okay, so this is not the case, but I am looking for an aqueous solution. Concentrated halogen, wait a minute, that would not allow hydroxide to discharge, because if you have concentrated halogen, that will discharge. So I'm left with this third option, C, which is my answer because I have sulfuric acid. We just saw that. Ethanol won't be an answer because ethanol isn't even an electrolyte. It's not going to ionize, it's not going to produce anything I need. A big shout out to pastmcqs.com for allowing us to do this. I really like their product, and I would suggest that you practice over there. If you have any friends who would like to sign up, just let me know. All right, so let's look at now theory questions. All right, aqueous copper 2 sulfate can be electrolyzed using carbon electrodes. Okay, so I have copper 2 sulfate. Again, what are the ions present? Copper ion, sulfate ion, and because it's aqueous, so I'm going to get H positive and OH negative. It doesn't say whether it's dilute or if it is concentrated, but that's really not important at this stage. Now they're saying write an ionic equation. Okay, so for the negative electrode is the one that pulls the cation. Okay, it's cathode. So let's see the competition between copper 2 and hydrogen, and the less reactive is the one that gets to become the atom. It's not something atoms prefer or not something that ions prefer, which is why the less reactive one is able to do it. Because, you know, this is reduction that they do, and metals try not to do that. So if they can avoid it, they will. And copper being less reactive has no option but to get reduced here. So copper goes there, gains 2 electrons, makes copper atoms, which you see as pink solid. A colorless gas was given off at the positive electrode. We can clearly see that that is coming from hydroxide, making oxygen gas. The solution changes color from blue to colorless. Why wouldn't it? This thing is blue, and this thing, once it's gone, the solution goes colorless because it's forming pink solid. So explain these observations. So we'll just say that hydroxide ion discharges to form oxygen gas, which is colorless. Okay, so I've explained the colorless gas. And then we say that copper 2 ions discharge. So their blue color fades. So that's the answer. You don't really need to get into the detail of why it forms colors and why is it blue, to be honest. That is something we study in A-levels, so you don't need to get into that. Okay. The reaction is at the negative electrode is the same, but the positive electron becomes smaller and the solution remains blue. So what's the difference? The difference is that in the previous one, they had, if you read it properly, carefully, they were using carbon electrodes, but this time they're using copper electrodes. So that is the minor difference, but it has changed absolutely everything, because now you are not going to get just copper ions from copper sulfate and all of these. You're also going to apply the first rule of electrolysis that we talked about, that reactive anode ionizes, and positive electrode is just another thing, name for anode. So yeah, the positive anode, the copper, it changes to copper ions and 2 electrons. So you are getting these copper ions as well in the mixture. So you're getting copper ions from the mixture. You're also getting copper ions from the anode, which starts to dissolve. Now explain why the color of the solution doesn't change. Because if any copper ions are discharged, there are more coming in from the anode. So the copper ions from anode are compensating or replacing for the ions discharge. So the color remains the same. Or you can also say that the concentration of copper 2 remains the same. What is the large scale use of electrolysis? Electroplating, that is one of them. You could use gold plating and all that. You could also use extraction of metals like sodium or aluminum or calcium or magnesium, because they're very reactive. So we try to use electrolysis for them, although it makes more financial sense to do it for aluminum because of high demand. And yeah, you can sell all that you produce. All right, so these are 2 main uses of this. Hydrogen can also be manufactured by electrolysis. Of course, electrolysis, the electrolyte is concentrated sodium chloride. Electrodes are inert. Okay, let's write the ions. Sodium ions, chloride ions, hydrogen ions, hydroxide ions. Okay, what are the products of these 2 electrodes? Again, let's circle the ones that are less reactive. Our rule says less reactive ones discharge. So I have hydrogen ions forming hydrogen gas. I already know that. and chloride ions forming chlorine gas, as I know that. So in the exam, they will not say what are the products. They will instead say, name the products or write the formula of the products or identify the products, something like that. They will use the command terms. So we will also say something like that, we'll say the products are hydrogen and chlorine, or you can also say hydrogen and chlorine gas. You don't have to make the full sentence. This is not English paper. All right, name the product that is left in the electrolytic cell. Okay, so if I have chloride gone and hydrogen ions gone, then what am I left with? Sodium hydroxide. And that's my product, sodium hydroxide. Now, because the examiner is saying that you have to name it, as you can see over here, you cannot just write the formula. You have to name it. All right. Name a substance that can be used as inert electrode. You could say platinum. Again, you have to name it. You could also say graphite, because both of them are inert. But graphite starts to react at high temperature with oxygen. Do you think the product will be different if electrolysis dilute sodium chloride? Of course, yes, a big yes to this. And the reason that at the anode, hydroxide ions will discharge, producing oxygen. It's important to mention why they're different, and I have to identify the products. Instead of chloride ions producing chlorine. So chlorine and oxygen are my products. Even if I don't name the ions, I still have to talk about the products that are formed. All right. And yeah, that is one basic test for electrolysis and some few questions that we usually asked. Let me know if you have any questions.